In the previous class, we were talking about transient response, RLC, parallel or series, step or natural response. And we have derived many equations, but at the end, I told you that we have to be sure that we are dealing with parallel RLC, 1R, 1L, 1C connected in parallel, or series RLC, 1R, 1L, 1C, or try to modify your circuit to be only 1R, 1L, and 1C. And we derived many equations, and based on these equations and the configuration of the problem, I can say I can use that equation or that equation. But I told you that the first step is to calculate alpha and gamma, and omega O, and then compare between them. And we can choose between 3 different equations. And after that, I have to find the initial conditions. If I'm using the current, I have to find I of 0 and di of 0 by dt. If I'm using the voltage equation, I have to find d of 0 and dv of 0 by dt. And based on these two equations, I can find the unknowns, which are A1 and A2, or D1 and D2, or beta 1 and beta 2. Let us see one more problem which is talking about that. Here, for this circuit, he gave me C and L and R. This is parallel RLC circuit. And for that circuit, he told me for the following circuit, if VO is equal to 0 and IO is equal to negative 12.25 milliampere, and it is downward. He asked me to calculate the roots and the roots of the characteristic equations, the roots and the characteristic equation. And also, he asked me to calculate V and dV of t at t is equal to 0. Actually, he gave me the value of V of 0. So I don't need to calculate V of 0. He gave it to me. What I need to calculate only dV of 0 by dt. Then he asked me to find the voltage response equation, V of t. Then he asked to plot V of t for t greater than or equal to 0 and less than or equal to 11 milliseconds. So for solving the problem, like what I told you before, I have to look to the circuit first and see if this is connected in parallel and series, if this is step or natural response. Based on what I have C connected in parallel with L, connected in parallel with R, and it is natural response. So I know that we are dealing with natural response. So based on that, I can say I have V of t, one of 3 different equations. A1 times e to the power s1t plus A2 times e to the power s2t, or theta 1 multiplied by e to the power negative alpha t times cosine omega dt plus beta 2 times e to the power negative alpha t times sine omega dt. Or V of t is equal to d1 times t times e to the power negative alpha t plus d2 times e to the power negative alpha t, based on alpha and omega. So for solving the problem, I have to find alpha and omega first, and based on the value of alpha and omega, I can say which one I can use. So I try to calculate alpha. This is parallel RLC. So based on that, I can say alpha is equal to 1 over 2 RC. If I try to substitute in this equation, which is the equation of alpha, for the value of R and C, I will find that alpha would be equal to 200. Then, if you try to calculate omega O, which is equal to 1 over square root LC, you will find that omega O will be equal to 10 to the power 3. If you try to compare between alpha and omega, you will realize that omega square is greater than alpha square. So I'm expecting that I have 2 complex conjugate solutions. So I have to calculate omega d, which is equal to omega O square minus alpha square under the square root, which is equal to 100 roots 96, or it is equal to 979.8. Based on that, I can say my equations will be beta 1 multiplied by e to the power, do you remember? Negative alpha t times cosine omega dt plus beta 2 times e to the power negative alpha t multiplied by sine omega dt. And then I have omega d, I have alpha. I will substitute in that equation. I don't need actually to calculate S1 and S2 unless he asked me, and he asked me to calculate the roots and find the characteristic equation. So I found S1 and S2. But I don't need actually if he didn't ask me about the roots. So if he didn't ask me about S1 and S2, there is no need to find them, because I'm not going to use them in my equation V of t, which is this equation. But if he asked me to find the roots, I have to find them. Then I will plug in this equation the values. So V of t will be equal to beta 1, which is unknown, multiplied by e to the power negative alpha times cosine omega dt, which is equal to 979.8 plus beta 2 times e to the power negative 200t times sine 979.8t. The problem here is for beta 1 and beta 2. I'd like to find them. For finding beta 1 and beta 2, I have to find the initial conditions. I have to find V of 0, and he gave it to me. So he gave V of 0 to me, which is equal to 0. And I have to find dV of 0 by dt. So dV of 0 by dt is equal to what? dV of 0 by dt is equal to what? Yes, IC of 0 divided by C. So this guy is equal to IC of 0 divided by C. Do we have IC of 0 in this circuit? Actually, he gave me IO. What is IO? IO is the current in this guy. He gave me only IO of 0, which is equal to negative 12.25 milliamps. But he didn't give me IC. How to find IC? Am I able to find the current in IR? How did you know it is 0? Yes, because he gave me the voltage, which is equal to 0. So the voltage between these 2 points is that voltage as well. Based on that, I can say IR of 0 is equal to VR of 0 divided by R. And I know based on V0 that VR of 0 is equal to 0. So I will say summation of the current for that node is equal to 0. And this is what I did here. I said V of 0 is equal to 0 and IR of 0 is equal to 0. Summation of the current is equal to 0. So IC plus IR plus IL should be equal to 0. And based on that, I can say that IR is equal to 0. Then IC is equal to negative IL. He gave me IL 12.25 milliamps. So negative will be positive. Based on that, I can say IC is equal to 12.25 milliamps. I will substitute by that value in the equation of dV of 0 by dt. So dV of 0 by dt is equal to IC of 0 over C. Based on that, I can find the value of dV of 0 by dt. Once you know dV of 0 by dt, and you know V of 0, you can substitute in your equation. what you have here, you have v of t is equal to beta 1 e to the power negative alpha t times cosine plus e to the power negative alpha t times sine. For t is equal to 0, sine 0 is equal to 0, right? So this term will be 0. And cosine 0 is equal to 1. And e to the power 0 is equal to 1, which means v of 0 is equal to beta 1. And v of 0 is equal to 0. So beta 1 is equal to 0. And this is what I did here. I said beta 1 is equal to 0. Then I will find the derivative for v with respect to the time at t is equal to 0 and substitute for finding beta 2. If you try to find beta 2, approximately it is equal to 100. So once I found beta 1 and beta 2, I will go back to my equation that I wrote here and substitute. I will substitute by beta 1 0 and beta 2 is equal to 100. Then I can say v of t is equal to 100 multiplied by e to the power negative 200t times sine omega d, which is 979.8 t. Based on that, I got this equation. And this is the equation for the voltage at any time t. He asked me to plot that between 0 and 11. I'll take a couple of points and I will connect them and I will draw my curve. Based on that, I got that curve. I'm not asking you to draw accurate curve. I asked you to sketch only that curve. So if you took like 3 different points and you connected those points, you will find that curve. And for sure, this is curve. It's not straight line. Do you have any question for that problem? Sure. Like what you are seeing, for all of the problems that we are solving, and for all of the problem in the assignment, what is needed is to know the initial conditions. V of 0 and dv of 0 by dt, or I of 0 and di of 0 by dt. After finding the initial conditions, I will find also alpha and omega O, and then I will compare between them. Then I will choose one of 3 different equations. And based on that, I can solve my problem. I have already uploaded the formula sheet. I'd like to show you that formula sheet. For the part that we are talking about here, it is this part. This is the part that I'm talking about. If you try to look to that, these are all different cases. Alpha parallel 1 over 2 RC. And omega O is equal to 1 over root LC. And omega, and sorry, alpha series is equal to R over 2L. I will distribute that. So you have to be able, you have to be sure that you are able to use this formula sheet. So I gave you 3 different cases for f of t, and I said f of t. I didn't say v or r, because all of these equations could be used for v or r based on the circuit. So I give you the general equation f of t is equal to a1 times e to the power s1t plus a2 times e to the power s2t. And I told you this is the natural response case. If we are talking about step response, what should I add? Plus f. It could be if or vf. So let us talk about the 2 different cases. I'd like you to pay your attention to that, because You are going to use that formula sheet for the final exam. If we are talking about parallel RLC, natural response, we are finding the voltage equation or the current. We derive the voltage or the current equation. The voltage equation. So if I'm talking about natural RLC parallel, we derived the equation of the voltage. Then what does f of t represent? It is representing v of t, right? If I'm talking about natural response RLC series, we derived which equation? Current or voltage? Current. So f of t is representing I. Are you seeing what I'm talking about, guys? This is very important. Let us talk about step response. For a step response, parallel RLC, we derive the equation for the voltage or the current? The current. So f of t is representing the current. F of t is representing the current. But here I have to pay my attention. I will say I of t is equal to a1 times e to the power s1t plus a2 times e to the power s2t plus if. This is in case of step response. In case of series RLC, and we are talking about step response, we derive the equation for the voltage or the current. The voltage. So f of t is representing the voltage. This is the tricky part. You have to put it in your mind. For a step response, parallel RLC, we derive the equation for the current. So f of t is representing the current. But for series RLC step response, we derive the equation for the voltage. So f of t is representing the voltage. Please go back to what I have already derived and try to remember, because in the final exam, you will need that. And here also, to make it more easier for you, I gave you the first derivative for the function, if it is voltage or current. For different cases, so you don't need to derive, sorry, you don't need to find the first derivative because I give it to you. You don't need to derive the first derivative. You will plug this only in your equation and substitute f by v or I based on the configuration of your circuit. Last question. Now, let us talk about another problem and try to use these equations for solving my problem. This is the last problem that I'm going to solve it related to that part. Let us see one more example. And I'm going to use the formula sheet to help me. This is parallel RLC circuit. And he told me the initial energy stored in the circuit is 0. What is the meaning of initial energy stored? It means V of 0 for the capacitor is equal to 0. And IL of 0 is equal to 0. This is the initial energy stored in the circuit. IL of 0 is equal to 0 and VC of 0 is equal to 0. Okay, guys? Now, he told me at t is equal to 0, a DC current is applied to the circuit. The value of the resistor is 400. So at t is equal to 0, this guy is opened. And he applied this source. So the circuit right now looks like parallel RLC, step or natural response. It's a step response. Let me go back here to this formula sheet. We are talking about parallel RLC. So I'm going to use this alpha equation. And I'm going to use this omega equation for calculating alpha and omega. And I'm going to choose one of these three different equations based on alpha and omega. But before I start looking to these equations, f of t here is representing what? I or v? It is representing I of t. But which I? It is IL of t. So, what am I going to do here? I know right now, what am I going to use? I'm going to use alpha and omega for choosing the equation that I need. And I know the equation will be IL of t. IL of t. And don't forget, in the formula sheet here, I gave you the equations in case of natural response. So don't forget, this is a step response. I have to add plus IF. Don't forget that. Okay? Now let us calculate alpha. Alpha is equal to 1 over 2 RC, and omega is equal to 1 over square root LC. If I would like to find them. But before finding them, let me read the problem again. He's asking me about the initial value of IL. What is the initial value of IL? It's 0. He told me the initial energy stored is equal to 0. Then he asked me, what is the initial value of DIL by dt? But I have to prove it. You are saying 0, but you have to prove it. So, DIL of 0 by dt is equal to what? V of 0 divided by L. Actually, VL. Right? Because this is IL. But since this is parallel, so this V is equal to this V. And he told me the initial energy stored is equal to 0. It means this guy is 0, so this is 0. You have to show me that. Then I asked you after that, what are the roots of the characteristic equation? I have to find alpha and omega. So here, this is what I did. I found IL and I found DIL of 0 by dt, which is equal to 0. Then for the roots, I have to find alpha and omega. Omega squared is equal to 1 over LC, which means omega squared is equal to 16 times 10 to the power 8, and alpha is equal to 1 over 2 RC, which is equal to 25 times 10 to the power 4. Now, I will compare between them. So, based on that, alpha square and omega O square, which one is bigger, alpha or omega square? Omega square is equal to 16 times 10 to the power 8, and alpha is equal to 25 times 10 to the power 4. This is alpha only. So the square of this guy will be 25 squared times 10 to the power 8. So alpha is greater or omega? Alpha is greater than omega. Which case? Is it over, under, or critically damped? It's over damped. So since you are talking about over damped, I'm going to see the over damped equation formula sheet, which is this one. But again, sorry, which is this one. But again, what is f of t? It's IL of t. So based on that, I can say IL of t is equal to IF, don't forget, plus those guys. What is the value of IF? Actually, the value of IF here is equal to 24 milliamps. So here I continue finding S1 and S2 because he asked me about the roots. S1 is equal to negative alpha plus square root alpha square negative omega O square, and S2 is equal to, by the same way, actually, I have J here. I forgot to write J. Oh, sorry, I don't have J because this is overdamped. I thought it's underdamped. I don't have J. I'm right. There is nothing. So this guy is S1 and this guy is S2. Now I'm going to write my equation. IL of t is equal to IF plus A1 times e to the power S1t plus A2 times e to the power S2. Don't ask me what is A1 prime and what's A2 prime. These are two constants. Why I call them A1 prime and A2 prime? Call them A1 and A2. Call them M and Y. Whatever. These are constants. Okay? Now, I will try to write the two initial condition equations. What are those? Actually, df of 0 by dt is equal to this guy and f of 0. So I'm going to write here IL of 0, which is equal to IF, which is given 24 milliamps, plus A1 times e to the power 0, which is 1, so I have A1, plus A2 times e to the power 0, which is A2. This guy is equal to 0. Then di of 0 by dt, it is equal to S1A1 plus S2A2. And you told me that IL of 0 is 0 and DIL of 0 by dt is equal to 0. So based on that, I have those two different equations. What is the next step? The next step is to solve these two different equations together. Yes, you pay attention. You are thinking for something, right? Pay your attention. I'm paying my attention to everybody as much as I can. So please pay your attention. This is very important. Now, you will use these two equations to find A1 prime and A2 prime. You know how to solve two equations in two unknowns, am I right? By using elimination or substitution or whichever method you are finding, it's more easier for you. If you're trying to find A1 and A2, A1 will be equal to that guy and A2 will be equal to that guy. Then I will go back to my equation. IL of t is equal to what? It is equal to IF, which is 24 milliamps, minus 32 milli multiplied by e to the power negative 20,000 t plus A2 prime, which is 8 milli times e to the power negative 80,000. This is what he asked me about. So for any problem like what you are seeing, talking about that story, it's straightforward. What you have to do first is you will try to figure out the problem is parallel RC or series RC, parallel RLC or series RLC, and then I'm going to find alpha and omega, and I will compare between alpha and omega. Based on alpha and omega values, I can decide which equation am I going to use. Then I will write my equation, and then I will try to find the initial conditions, and then I will try to find two different equations, function of two different constants, then find those constants, then plug them again to find I of t. Any question for that, guys? Yes. IF is given, which is the source current. It's given in the problem here, which is the source current. Which is this guy, 24 milliamps. No, it's not the initial current. This is the forced current. That's why we are calling it IF. But the initial conditions are the initial voltage or current in the inductor and the capacitor. Okay? Yes.
Instead of IF, we have EF, and we have to calculate I.
You have to convert the problem to be similar to what you have already derived. Because I derived some equations, so I have to have similar to those. Any question, guys? What we have already covered is transient response. What do you mean by transient response? I mean, I'm talking about a small period of time, charging and discharging. And then after charging and discharging, after charging, the switch will be moved to discharge. So this is what we are calling transient response. I have switch moving from a certain position to another position. But what about if I'm talking about steady state? What is the difference between steady state and the transient? Transient state means you are talking about a small period and a huge disturbance happened in the system. Like what we have. We are talking about a specific period and a huge thing happened, which is charging. But if we are talking about small thing for a long period of time, this is what we are calling steady state analysis. So chapter 9 is talking about the steady state sinusoidal waveform. Imagine I have a capacitor or an inductor connected along with a voltage source or a current source. And I would like you to study this problem to find the voltage or find the current for a specific branch. The problem is what? The problem is I will not have only parallel RLC or series RLC. I have more complicated circuit. So for each circuit, I'm going to write my equation, which is summation of voltage is equal to 0 for each loop, and summation of the current for each loop is equal to 0. Then I will have many differential equations, and I have to solve them. But dealing with differential equations is not easy, right? That's why we have to find a specific tool which will be more easier to be used to simplify solving the problem. And this is what we are going to talk about in chapter 9. Did you hear about Laplace transform? Why we are using Laplace transform? We studied it in mathematics. That's why we use it. Yep. But why?
I don't remember.
Any answer? I know you studied it in mathematics. It is a mathematical technique you are using for solving the problem. But why? There is a reason. Excuse me? Any explanation for that? The easiest explanation is we have some differential equations, and it is hard to solve these differential equations in time domain. That's why we are doing what? We are converting the problem from time domain to another domain, which is called Laplace domain. Solve the problem in Laplace domain because I'm going to convert the differential equation to the polynomial equation. And it's very easy to deal with polynomial equation. Solve the problem in Laplace domain and then go back to time domain. So Laplace is only a method that I'm using to simplify solving the problem by transforming the problem from a specific domain to another domain. Like today, for example. Today you are here for what? For understanding what I'm talking about. So you moved yourself from your apartment and came here to my domain to be able to understand. Then you are going back to your domain to study. Right?
This is what we are going to do. We are going to convert the problem from its domain, which is time domain, to another domain, which is called phasor domain. Why we are doing that? Because we would like to solve polynomial equations instead of solving differential equations. Because solving polynomial equations is more easier compared to differential equations. This is the story for chapter 9. We are going to convert everything from time domain to phasor domain. But before I start talking about that, I have to understand some simple things. Like what? Like this waveform. I have to understand how to deal with that waveform. Imagine I have a waveform like this one. What is this waveform? Is it sine or cosine? Is it sine? It is sine waveform. So this waveform is written as f of t is equal to f max multiplied by sine omega t. What is f max? F max here is representing the maximum value. So the maximum value is represented by f max. So this guy is representing f max. There is something else which is called peak to peak value. What's peak to peak value? It is equal to the distance from this guy to this guy, the distance between positive and negative peak, which is 2f max. So this guy is called peak to peak. This function is repeating itself after a specific period. That's why we are calling this function as periodic function. Because it started from 0 here, increased, then decreased, then increased, then reached 0, then it will start to repeat itself again. That's why we are calling it periodic function. And the periods that is needed for that function to repeat itself after is called the periods. So t here, the period for that function, is equal to t. Based on that period, there is a new variable which is called the frequency. And this is equal to 1 over the period. And its units will be hertz. Since right now you are talking about AC, because I have variable values for f. We studied before, when we were talking about the voltage or the current, we studied that the voltage is constant or the current is constant. But today, we are talking about voltage which is variable. F is representing voltage or current. We are talking about voltage or current which is variable. It is not constant. So, if I would like to measure the voltage or measure the current, the voltage that I'm going to measure for the current is not constant value. If I'm trying to use oscilloscope, I'm going to use variable values. Am I right? But if you're trying to use the multimeter, are you measuring variable voltage or variable currents? You did that in the lab. You were measuring what? Yes, voltage. Its value was variable or constant? Constant. Right now, if I try to measure the voltage from this outlet, it's 110. For example, 110, 115, 120, something around that, 109. So this voltage is variable or constant? Excuse me? No, if I'm trying to use the multimeter, it will give me one value. Right? After 1 hour, I try to measure it, I'll see the same voltage. Are you going to see 0 voltage and 100 and 110 and 90? Or you are going to see a constant value? Constant value. So, are we using in this rule AC or DC? AC. We know AC. But while I'm measuring the voltage, I'm measuring constant value. No? Yes, because we would like to find a specific characteristic that will represent a constant value of the voltage. Those who are dealing with that try to reach to a specific value that will represent the characteristic of that voltage instead of measuring different values. And this value is constant, but I'm using AC. But the value that I'm measuring it is constant at any time. What is that value? They are calling it root mean square. So we have two different things. Number one, mean or average value. And they defined the average value as 1 over the period integral from the 0 up to the period for the function f of t dt. Okay, so if I try to go to this equation and look to the graph here, integral from 0 up to t, which is the period, this integral will be equal to what? Oh, it will be equal to 0. So they found that I couldn't use the average to represent that quantity. Why? Because all currents and voltage that we are going to use are sine or cosine waves. So if you try to find the average, it is 0 in all cases, which means I will not know the value or the actual value of the voltage. That's why they said we will not use the average. We will try to use something else, which is called root mean square value. What is the root mean square value? Actually, we are calling it RMS. What is the root mean square value? It is equal to the root. For what? For the mean after squaring it. So it is 1 over t for integral from 0 up to t for f square of t dt. It is, from its name, root mean square, the roots for the mean after squaring it. Why I'm squaring it? Because I don't like to have negative and positive to cancel each other. I would like to have positive only. And they found that the root mean square for any sine or cosine wave, if it is a pure sine, I didn't cut part of it, like by using diode and cut some parts. No, if it is pure sine wave and pure cosine wave, the root mean square for any sine or any cosine wave is equal to the maximum value divided by root 2. This is what they found, and you can prove that if you want. If you will study with me circuit analysis next term, I'll repeat that with you again, and I'll show you how to find that. And I can show you example next class if you want. But right now, I would like to know that the root mean square is equal to the maximum divided by root 2. Now, imagine, for example, I have
V1 of t is equal to 50 sine omega t. What is V1 RMS? Yes. This is the RMS value. You will realize after that this guy has angle 0. And this is what am I going to talk about next class. I will start talking about phasors. This is representing the angle. What is the angle? Wave like this waveform started here from 0. That's why I am calling its angle, the starting angle for this guy is 0. But imagine I have a waveform here, started after a specific angle. So the root mean square is maximum over root 2 and a specific angle. And this will be our story for next class. If I have resistor in time domain, and I would like to convert it to phasor domain. If I have inductor in time domain, and I would like to convert it to phasor domain. If I have capacitor in time domain, what does the capacitor in phasor domain look like? So, next class, I'll talk about any voltage in time domain, how to convert it to phasor domain. Any current in time domain, how to convert it to phasor domain. Any resistor in time domain, how to convert it to phasor domain, and the same for the capacitor and the inductor. Once I converted everything in my circuit to phasor domain, I am going to solve my circuit in phasor domain, and I'm not going to see any differential equation. Why? Because if you are talking about phasor domain for the capacitor, the voltage across the capacitor in phasor domain is equal to the current I multiplied by negative J, which is a complex number, times something we knew that we are going to talk about next class. It is called X, the reactance. And we will not say V is equal to 1 over C integral of I dt plus the initial voltage. Why? Because I converted my capacitor from time domain to phasor domain to cancel the integral, to cancel the derivative. And at that time, I am going to deal with polynomial equations only. But the problem is what? The problem is I am going to see complex numbers. I am going to see real and imaginary, polar formatting or rectangular formatting. So, please, if you have time, try to go over the complex numbers that you studied before. If you don't have time, that's okay, because on Monday I'll talk about complex numbers before I start talking about the lecture. Thank you, and have a great weekend. I'll see you next week. Do you have any question? Okay. So I'll see you next week.